Dear students, so through these sessions of software engineering and testing, we have learned about the emergence of software engineering, the different software engineering lifecycle models, software project management, requirements analysis and specifications, and software design. How to design function-oriented modules and non-functional modules. And now we learn about user interface design. What is the importance of having a good user interface in our software, and the basic concepts and the types of user interfaces that are being used in a software. So with these knowledge of software engineering, we are going to the other phase of the software engineering process, that is coding and testing. So far we have learned about developing a design document from the SRS document, and in that we have learned about the module specification document also. So this design document and the module specification document forms the input for coding process. The input to the coding phase is the design document, and the module specification document produced at the end of the design phase. See, through the design phase, not only we have created the design document, that means the design document is not meant for merely creating the high level design of the system. Different modules are formed at the design document. For example, we form a structure chart out of the SRS document in the design process, and also it contains a detailed design. The detailed design contains the flow of data from one module to another. So after completing the design process, software designing process, we may have a complete document, a structured document that contains all the modules specified in it with the exchange of data, flow of data between the modules. So these are all contained in a design document, and this forms the input for the coding phase. The detailed design is usually documented in the form of module specifications, where the data structures as well as the algorithms for each module will be specified in that. So during the coding phase, different modules identified in the design document are coded according to their corresponding module specifications. So the objective of the coding phase is to transform the design of a system into code in a high level language. And after completing the coding phase for each modules, these modules will be unit tested. So with the coding phase, the design of the system is implemented in a high level language. The implementation of the design document into a high level language is done at the coding stage. That means it will be the algorithms and the data structures that are formed at the design phase will be implemented or written in any of the high level languages, and the language will be chosen according to the document or according to the software that is to be developed. So this is the objective of the coding phase, that is to transform the modules in the design document. The design document and the structure chart or the module specification document contains all the individual modules. All the functionalities of a software will be specified as individual modules. We have learned all the terms earlier. All the functionalities of a software will be specified as independent modules in module specification document, and it also contains a structure chart, that is a detailed design of how the data flow from high level modules to low level modules, or all these interactions between the modules are specified detailed in that detailed design document. So from the detailed design document or the module specification document, all these data structures and algorithms are implemented into a high level language, and this is done on the coding phase. Immediately after implementing each and every individual modules into a high level language, these individual modules are tested, and the testing done on individual modules of a software is known as the unit testing. The unit testing is done immediately after completing the coding phase. After coding the individual modules, these individual modules are unit tested. Testing done on individual units or modules is called the unit testing. Now, every good software development organizations require the programmers to implement to some well-defined and standard style of coding. And every organization may have their own coding standard. Some software organizations formulate their own coding standards that suit them the most, and they want their developers to follow these standards. Somehow, every organization should adhere to some coding standards, because the coding standard gives a uniform appearance to the code written by different engineers, as these separate modules may be implemented by different engineers. After all, after implementation, the coding must have a uniform appearance. For this, a coding standard is useful to have a uniform appearance to the code that may be written by different engineers. And this uniform coding standard or uniform coding style helps in better understandability of the code, because the code implemented by different engineers may be implemented or may be maintained by another set of engineers. So in that case, there is a importance in the better understandability of the code. So adhering to a particular coding standard helps in better understanding of the code. And of course, it promotes good programming practices also. It helps in the better understandability, and it promotes the good programming practices. So coding standards have to be mandatorily followed by the programmers, and these coding standards are verified before the testing phase can start. There is a difference between coding standard and the coding guidelines. The coding standards have to be followed by the programmers, and these adherence to a particular coding standard is always verified before the testing phase starts. Coding guidelines provide some general suggestions regarding how to how to implement a particular algorithm or data structures, regarding the coding style to be followed. But actual implementation is, of course, it is left to the individual developers. It just provides a certain or particular suggestions, general suggestions on how to implement a particular data structure or algorithm. But the actual implementation of that will be left to the individual developers. And all these coding standards will be verified after completion of the coding phase. Before the testing phase starts, the adherence to a coding standard will be verified by a team of members. After a module has been coded, usually code review is carried out to ensure that the coding standards are followed and also detect as many errors as possible before testing. So it is important to detect as many errors as possible during code reviews, because reviews are an efficient way of removing errors from the code as compared to the defect elimination using testing phase. So it is a better way to detect the code errors in the code review stage itself. The code review is important in that it helps in detection of as many errors as possible before the testing phase starts, and it is an effective manner. It is effective in detecting much more errors than it is being eliminated during the testing phase. So code review has an important role in the software development process in detecting the errors. So we shall go deep into the coding standards and guidelines. As we have said, good software development organizations usually develop their own coding standards and guidelines depending upon the software or depending upon their organization, the way that suits their organization best and based on the specific types of products they develop. They may have various kinds of a particular kind of software coding standard or guidelines are followed by every good software development organizations. So some of the representative coding standards are listed here. First one is rules for limiting the use of globals. And we know the global variables helps a lot in a program coding, but the use of global variables should be limited for better understandability of the program. So these rules list what types of data can be declared global and what cannot be declared as a global variable. So this rule is formed with a view that the data, global data specified on a software should be limited. To limit the data that needs to be defined with global scope. All the variables or a maximum number of variables on a program should not be declared as a global scope. The global variable should have a limited purpose, or a limited number of variables should be declared with a global scope. Otherwise, it leads to many of confusions in coding. And standard headers to precede the code of different modules. We know the headers are important in helping the understandability of the program. So the program must have some header format, and these header format are also differs from organizations to organizations. Some of the headers that must be included in a program coding are name of the module, date on which the module was created, author's name, modification history, synopsis of the module, and different functions supported in the module along with their input, output parameters. And the global variables that are accessed or modified by the modules. So the headers for each module should contain at least these data, so that anyone else from the developing team can better understand the module, the function of that module with by reading its synopsis, or by getting the functions that are being used in that module and the different data, that is the different input and output parameters used with that module, and the global variables that are supported, that are used and that are modified by the modules. So the module must have headers at least specifying these details. And there are specific naming conventions for the global variables, local variables and the constant identifiers. We know the generally used conventions for specifying the variables or global variables would always start with a capital letter. We usually specify the global variables starting with a capital letter, and the local variable names start with small letters, and constant names are specified with capital letters only. We know these are some general conventions used for naming the variables. Usually a popular naming convention is that variables are named using mixed case lettering. But we use this convention, that is, it provides better understandability of the program. So we specify global variables with starting with capital letter, and local variables with small letters, and constant variables are always specified using capital letters only. There is a way for there is a convention for error detection or error return values also. So conventions regarding error return values and exception handling mechanisms is that all functions when encountering an error condition, the function should return a 0 or 1 consistently. That is what we are using throughout the programming, whether it is whether the program may be done using any high level language. The general convention of returning an error value is that the function may either return a 0 or 1 consistently, independent of the programmer or independent of which programming language they are used. It is a general convention to use this mechanism of error return values, either to return 0 or to return 1. So the way error conditions are reported by different functions in a program should be standard within an organization. And representative coding guidelines. All these we have said is about the representative coding standards. And then coming to the representative coding guidelines. Do not use a coding style too clever or too difficult to understand. That means coding should be easy to understand. Many experienced engineers may write cryptic, incomprehensible code, and these may hamper the understanding of the program, because the engineers who are engaged in the development of that or implementation of coding may not be engaged with the maintenance of the same project. So in case of maintenance of a project, these comprehensive or these cryptic code, too clever code may hamper the understanding. So it may make maintenance and debugging difficult and expensive. And the next one is the side effects of a function call. That is the module or the modification of any parameters passed by reference, or modification of global or local variables, or the input output operations. Any side effects of this function may cause or it may affect on the proper understandability of the code. So the proper guidelines for the development of a software is that we should avoid obscure side effects while specifying or while passing parameters. That is, if a module is meant for modifying or altering any global variables or IO operations, that should be clearly specified. Otherwise it may become difficult to understand a piece of code with some obscure side effects that are caused by some modules. It becomes difficult to infer some from the function's name and header information, and it becomes difficult to understand the code. So avoid all these side effects while forming the modules and while coding the modules. And next one is do not use an identifier for multiple purpose. See, some programmers may use the same variable names for multiple purposes. The reason behind this may be for memory efficiency. For example, 3 variables use up 3 memory locations, whereas the same variable used for 3 different ways use just 1 memory location. So, for memory efficiency, different programmers may use the same identifier for multiple purposes, but even if they may use it for memory efficiency, it could not be supported, because each variable should be given a descriptive name indicating its purpose. This is not possible if an identifier is used for multiple purposes. Use of a variable for multiple purposes can lead to confusion and make it difficult for somebody trying to read and understand the code. And use of variables for multiple purposes usually makes future enhancement difficult. For example, we may need to change the type of the final result to integer or from integer to float type. And in such cases, if this same identifier may be used as another temporary loop variable, this may cause error in different parts of the program, which may be left as unnoticeable, or which may cause a further and predictable output in the program. So it reduces the understandability, and also it makes the maintainability of the project too difficult. So an identifier must be used for a single purpose. Do not use an identifier for multiple purpose. Even if it promotes memory efficiency, it should not be supported in any case. And the code should be well documented. That means there should be at least one command line on the average of every 3 source lines of code. The command line helps in understanding the functionality of the statement. So there should be at least one command line on the average of 3 source line code. And the length of any function should not exceed 10 source lines. See, a very large function may contain very large bugs also, errors also. So a lengthy function is usually very difficult to understand, and it probably has a large number of variables and carries out many different types of computations, because for the same reason lengthy functions may have larger number of errors also. So the length of any function should not exceed 10 source lines. And also another one is we should not use goto statements. Goto statements should be limited in a program. Use of goto statements makes a program unstructured, and it makes it difficult to understand, debug and maintain the program. So goto statements should be possibly avoided in the coding part of a software. So these are all the guidelines for coding, and we have learned about the standard coding and standard guidelines, coding guidelines. Another important part of software development process is the software documentation. When a software product is developed with its necessary source code, in addition to this source code, several kinds of documents are also developed. User's manual may be there, and software requirement specification, as we learned earlier, and design document, test document, installation manual, etc. These are all important documents, necessary documents that support the use of the particular software. So these are the development or the documentation of the software is also a part of the software engineering process. And all these documents, whether it may be the SRS document, user's manual, or software design document, test document, etc., all of these are considered to be as much important as the source code itself. Good documents are very useful because good documents help enhance the understandability of a software product, and the availability of good documents help to reduce the effort and time required for the maintenance. Documents help the users to understand and effectively use the system. See, user's manual is much important for the user. Without a user's manual, any end user could find it difficult to use the software. So it is needed for the better understandability of the program, and it helps in reducing the effort needed for the maintenance, and it helps in effectively tackling the manpower turnover. That means if even when an engineer leaves an organization and a new engineer comes in, he can build up the required knowledge easily by referring to the documents. So the training that may be needed to give for a new engineer can be reduced with a good document. It helps, a good document helps in effectively tackling the manpower turnover problem. And production of good documents help the manager to effectively track the progress of the project. As the software development process or the software does not have a physical appearance, it is important to identify or track the progress of the project using the documentation of the project. The project manager would know that some measurable progress has been achieved if the result of some pieces of work has been documented. And by reviewing these documents, he can measure the progress of the project. So, software documentation can be broadly classified into two types: internal documentation and the external documentation. Internal documentation is the coding itself. The source code itself forms the internal documentation. External documentation, it is very important to have external documentation for each software because it contains all the supportive files for the users, and it provides us supportive files for the maintenance of the project for future enhancement. So internal documentation is the code comprehension features provided in the source code itself. And this documentation can be provided in several forms, maybe comments embedded in the source code, use of meaningful variable names, module and function headers, code indentation, code structuring, and use of enumerated types, use of constant identifiers in use of user-defined data types. That means the internal documentation helps a development team or the engineers for effective understanding of the source code. So for a better understanding of the source code, of course command lines must be given in a source code, and each and every module should have headers, and we have learned what a important header must have. It must have the function, it must specify a synopsis of the module with the author name, or how the module is implemented, whatever may be the module functions, and what data may be used by the module as input, and whatever may be the output given by that module, and what may be the parameters used in that module, and the coding structure, that is what may be the high level module, and how the high level modules are splitted into lower modules, and the usage of global variables in that program, and all the enumerated data types or user defined data types used in that modules. These all must be specified, so that this internal documentation helps for the development engineers, even for maintenance of the project. And experiments suggest that out of all types of internal documentation, meaningful variable name is most useful while trying to understand a piece of code. It helps the most. The meaningful variable names in a program helps much more in the understandability of a program. And for each and every lines, as we said earlier, for an average of 3 source code, the developer can specify a command line For example, if he assign a value to a variable, it must be specified using a command line. For a equal to 10, it must be specified using a command line that a is made to 10. So it promotes the understandability of a program. So the average usage of the command line is each 3 lines of source code may contain a command line. A good style of code commenting is to write to clarify certain non-obvious aspects of the working of the code rather than cluttering the code with trivial commands. Do not use unnecessary command lines in a source code, but whenever the source code is to be clarified, we must have to provide the command lines. Good software development organizations usually ensure good internal documentation by formulating their coding standards and coding guidelines. And with external documentation, the external documentation is provided through various types of supporting documents such as user's manual, software requirement specification document, design document, test document, etc. All these forms the external documentation, and all these forms the supportive files for the end user as well as the maintenance team. And this ensures that all these documents are produced in an orderly fashion. This must be done in an orderly manner. However, the important features required for any external documentations are the documentation must be consistent. External document must be consistent. Any inconsistent document may lead to a lot of confusion while trying to understand the product. It may lead to a lot of confusion. So the external document must be consistent. And another important feature is it should be up to date. All documents developed for a product should be up to date, and if any change is made with the coding, it should be reflected in the external document. Any change in the codings must be reflected in the external document also. So it must be up to date. Another important feature required for external document is proper understandability by the category of users for whom the document is designed. So there are many techniques used for providing better external documentation, but we are not going deep into all those things. And I hope you understand this well. Keep learning. Thank you.